Welcome back to the chapter number 3 of the electric machine 1. Myself, Professor Jay Tandil from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we will going to learn about the basics of electric machine, principle, its construction, some visualizations of the magnetic field, right, air gap flux density, flux per pole, and some induced EMF in the armature coil. So today is the beginning of chapter number 3. So let's start with the construction. Now as you see that there are 4 pole machine, 1 2 3 4. It's having a series connection of winding and it's having a 2 terminal. So that is generally called as a field winding, right? Whatever in which the field is wound, that is which is fitted on yoke with the help of screw and bolt arrangement, right? And the end of this pole, that is called as a pole shoe, which is little bit this area of the little bit higher and spherical shape, so magnetic field is spread out. So these 4 are pole with the pole shoe which is mounted on yoke. This is a yoke, means the body of the machine, right? So this whole thing is not rotate, right? That is a stationary thing. You can see between the air gap and after that rounded some slots and teeth you can see over here. They will also have a supply. With the black color is indicated some brushes arrangement and some this dotted this horizontal line which is indicate the ring, that is a commutator arrangement, and the black another at the end center of that black, that is a shaft. Okay, so this whole thing is rotate actually. Okay, how this will be rotated? It will be rotated with the help of when the supply is given to that. What will happen? Whenever the current carrying conductor placed between a magnetic field, it experiences a mechanical force. This is a basic DC motor principle, right? So this thing is rotated, means that is called as in case of DC it's armature, right? So armature is rotated. Armature having a main armature winding, armature core, some commutators, and commutator which is connected with winding. Commutator having a different function. In case of motor is different, in case of generator is different. So construction wise machines are same, that's why motor and generator having a same construction. Only the difference is that somewhere we are collecting some current in case of generator, where in case of motor we are giving the supply to that. So in DC machine, first thing is clear, both armature and field both having a supply, right, where the induction does not have. So if you are talking about the main part, then it's a terminal box, it's a yoke, this is a pole having a field winding, this is armature core having armature winding, brushes, and some commutator ring, that is. So commutator is actually rotate, brush is a stationary thing, right? So brush with the terminal is stationary thing and other things are rotates. Okay, now construction wise, there is a descriptions of the construction. First main, that is a yoke. Yoke is outer frame, right? It is made up of cast iron or steel. It is only provided the mechanical strength to the whole assembly and also carry the magnetic flux which is produced by the field winding. Second one, that is pole and pole shoe. As I told you that pole having a winding which is called as a field winding, pole shoe having a larger cross section, so that's magnetic field spread easily, right? So the poles are jointed to the yoke with the help of bolt, as I told you, or welded. It's carry the field winding and the pole shoe are fascinated to them. So the pole shoe serve the two purpose. First, that is a support the field coil. Second is spread out the flux in the air gap uniformly, right? See over here you can see the gaps are uniform. It is not like that somewhere having a larger gap, somewhere having a shorter gap. It's having a uniform gap, so uniformly flux are to be distributed. Now field winding as I told you is a stationary. They are usually made up of copper. Field are formed to wound and place on the each pole are connected in the series. So they are wound in such a way that it is energized with the help of some DC supply, or from, and it will be alternately from north pole and south pole. So this is regarding to the construction main three parts. Another, that is armature core and armature winding. Armature core is a rotor of DC machine. We can say it is a rotating part. It is a cylindrical in shape with the slots having a armature coil or armature winding, which is carry the current. So your armature is built of a thin lamination circular steel disc for reducing the eddy current. Now what is the eddy current and hysteresis loss we will discuss later, right? And my approximately ninth lecture number 9 we will discuss about the eddy current losses, hysteresis losses and losses in machine as well as efficiency. Now second, it may be provide the air duct for the axial airflow for the cooling purpose. So armature is a shaft, keyed to the shaft. Now armature winding, so it is usually formed to wound a copper coil which is the rest in armature slots equally. The armature conductor are instead from each other and also from the armature core. Armature winding can wound by one of the two methods. First, that is called as a lap wound and wave wound. Double layer lap and wave wound, simplex wave. These are some of the types we will discuss on lecture number, I think, 5. There is a armature winding and types of armature winding. Now another important thing, that is a construction of main part, that is a process and commutator arrangement. So actually we know that rotor is, armature is rotate, but we need to give supply to the winding. So that's why brushes and commutator are to be connected in such a manner. Brushes are stationary, commutator with the shaft are rotated, which is connected with the armature coil. So continuous supply will be provided to them. So the function of commutator in case of DC generator to collect the current which is generated in armature. In case of generator, what will happen? Generate the current in armature. So we are collecting purpose, we are using a commutator, where in case of DC motor we are using it for rectification purpose. So in case of DC motor, commutator help to provide a current to the armature winding. So first, in case of generator it will be collect a current, in case of motor it will be given to the current. So commutator is consist of set of copper segment, it is nothing but. So that's why brushes, after some time, after long time, it need to be replaced, right? Because it's having some losses. Yeah, and when we are talking about some armature circuitry on lecture number, I think, 4th, right? So in that we are discuss about armature circuit and what is how we can count the armature voltage drop, a brush voltage drop, right? Nextly, the brushes are usually made up of carbon or graphite. Brushes are made up of carbon or graphite. So they rest to the commutator segment and side the segments when the commutator is rotate, keep in physical contact to the supply of the current. So these are the basics about the commutator and brushes, armature and armature core, pole, yoke, pole and pole shoe and field winding. So and the GTU in which exams in exam maybe the question is like explain the construction working principle of the DC motor. You need to write like that, right? Now classifications of the DC machines. The DC machine are classified into exactly 3 category: separately excited, right, permanent magnet type also, and self excited. Separately having a field and armature both having a separate supply, where the self excited, that might be know about that. Self is divided into 3 parts: shunt, series and compound. Compound further divided into 2: cumulative and differential. Differential and cumulative further divided into 2, that is long shunt differential and short shunt differential. So these are the types. Now working, as we discuss in Google Meet, right? Working principle is most important part of the motor, right? Definition wise I repeat that: whenever current carrying conductor placed between magnetic field. So we need a current carrying conductor. So suppose I am consider one conductor set, I am considering only one conductor set. There are so many sets of conductor are like that, like I am considering only single bunch of conductor set which at one point is connected with positive and other that is connected with the negative. So whenever current carrying conductor, so we need to current carrying this thing, so that's why we are placing a supply to that, right? So for giving the supply, these are the slip ring and brushes are arrangement in such a manner that whether this winding is rotate is continuously supplied by this commutator and brushes segment. So whenever the current carrying conductor means this thing place between magnetic field means N to S, there is a magnetic field, it experiences a mechanical force according to the F is equal to BL I sin theta, right? BL V sin theta somewhere, BL Therese I write, right? So and the directions of the rotation that will be decided by Fleming left hand rule. It is like that. So first finger is indicate the direction of magnetic field. So if the magnetic field is like that, second finger which is indicate a direction of current. So see, if you are talking about the red side, so direction of current is like that, right? So लाल माथी current આવશે, right? The red माथी current આમ નીચેની તરફ આવશે because according to the Fleming this rule. And first finger is indicated direction of thumb. So red line છે ત્યાં કા force generate થશે upper side, where it is exactly inverse for this thing. Why? Because when a first finger is indicate over here, so but obvious when the force is upward direction in red line, so blue line force is downward direction. So if your thumb, you need to be change thumb on bottom side, so what is the direction of current? That will be in that direction. So this is the direction for blue, this is the direction downside, that is for red. So continuously current will be flowing. F is equal to BIL sin theta, we can say BL V sin theta. B, that is magnetic flux density, I, that is the current, L, that is the length of conductor within a magnetic field. So when the armature of the motor is rotating, what will happen? The current are also cutting the magnetic flux line. So hence according to the which principle? Faraday law of electromagnetic induction, what will happen? EMF is induced in the armature conductor. So directions of this induced EMF which is oppose the armature current IA in the circuit. So directions of the back EMF and armature circuit could be fine. So this is regarding to the principle. All the machines, whether it is DC or AC, it's work on a basic principle of induction. If you give the supply to the one solenoid which having a winding, it will be generate a flux on the other winding. Okay, now most important theory, that is EMF equations of the DC machine, right? DC motor, what is the EMF? So where you know that when the supply is given to that, what will happen? Some of the EMF that will be generated over here. So how it will be generated and what are the equations of that, we will discuss that. So first of all, for defining the EMF equation, let's consider flux 5, that is a flux per pole, which is unit is Weber, and P is equal to number of pole in DC generator. So the total flux means what? Total flux, there are number of line of flux which is indicated by 5, it having a pole, right? So we can say total flux which is responsible for the pole. If 2-pole machine flux is different, if 4-pole machine flux is different, right? So flux into P, that is indicated by total flux which is produced at a particular pole. Total flux is produced by the all pole, which is indicated by how the winding is to be rotated. So we are considered as a 60 second per rotation means N. So 60 by N. So N, that is the speed of armature conductors in RPM. So now according to the Faraday law of electromagnetic induction, we are denoted E, which is E means what? How the EMF is generated when some flux is cut by the conductor, right? So with respect to time, so E is equal to, we can write d phi by dt. So E is equal to total flux by time is taken, but we need to know that d phi by dt, flux d phi means what? Equation number 1 we are putting over here. D phi is replaced by equation number 1 and dp is replaced by 60 by n, that is a time period. So flux pi divided by 60 by n. So n, that is on upper side, so p phi n divided by 60, that is equation number 4. Now conductors, number of conductor, its gauge having a matter, right? So we are consider as a armature having a as we discussed, it is a two types of winding, lap winding and wave winding. So winding configuration will be affect the EMF equations. So now consider Z is equal to number of conductor in generator. We how much conductor? There are a bunch of conductor, not only one conductor which is wound over the motors armature, right? There are bunch of conductors. So let the Z is the total number of conductor in generator, which is arranged in all parallel paths. Suppose parallel path we are consider is equal to A. So the parallel path that will be different for the lap winding and wave winding. Lap winding, for that number of parallel path A is equal to number of pole, where in case of wave winding the number of parallel path is equal to 2. So yeah, winding arrangement that will be affect on performance of the machines as well as EMF equations. So EMF equation having some another term which is added, that is Z by A, number of conductor divided by number of parallel paths. So EMF induced E is equal to P phi and 60 divided by Z into A, that is equation number 5. Now it will be, as I told you, depend on the winding. Suppose lap winding, then Z is equal to A, number of parallel path A is equal to in case of wave winding it is 2. So we can simply put P phi and Z divided by 2. So 60 to 2 120. So 5 P and Z divided by 120 for which winding? Wave winding. For lap winding is equal to P is equal to number of parallel path A. So EMF equation P phi and Z divided by 60 into A. Thank you.